fellow mathematicians. For today's lesson, you're going to want to download a worksheet available on my Teachers Pay Teachers account. You can find the link in the video description. You're also going to want some blocks. They can look like these or whatever kind of linking blocks you want. Something that'll link together so that you can count the inside and the outside.
Math. Numbers.
Sine wave.
Coordinates.
Radius.
Let's factor. Let's factor more.
Polynomials.
Numerator.
Equation.
In this activity, the student is asked to build a tower, each layer of which consists of 4 blocks. They need to find the volume of the tower after adding each additional layer. Another way to think about the volume is how many blocks are inside the tower. As you can see, when we add a second layer, we're adding 4 more cubes for a total of 8 cubes. Out of this, we make an ordered pair of x and y, 2, 8. If we add another layer, we're adding 4 more for a total of 12. The student should hopefully notice fairly quickly that as the number of layers in the tower increases, the total number of cubes increases by 4. In other words, to calculate the volume at a given layer, you would take the number of layers, x, and multiply by 4, thereby giving you the equation y equals 4 times x. On page 2, the student will graph his data and then identify the rate of change in the y-intercept. If the tower adds 4 cubes per layer, that means that the rate of change is 4. The y-intercept is going to be the number of cubes at 0 layers. If we have 0 layers, we should have 0 cubes, so the y-intercept would be 0. Recall for a moment the difference between discrete and continuous. Discrete variables can be counted. They're usually whole numbers, versus continuous, which is something such as running water or time that cannot be counted but could possibly be measured. So if we think about our blocks, we only are using whole numbers of blocks, whole numbers of layers, and so therefore this is discrete. All we have to do for the domain is list out all the possible values of x. And technically we could keep adding layers for as long as we wanted, so we can end with a ... In other words, an ellipsis. Now we're going to rebuild our tower all over again, this time paying attention to the surface area. So if I'm looking at one layer, I'm going to count all the squares showing on the outside. So you'll notice I have 2 on each of the sides, and then 4 on the top, 4 on the bottom. When I add those together, I get 16. If I add a second layer, now I have 4 on each of the 4 sides, and then I still have the 4 on the bottom, 4 on the top. When I add those together, I get 24. Now, if I add a third layer, I don't have 4 on each side anymore. I have 6. So 6 on each of the 4 sides, plus the 8 that are on the bottom and top. And when I add those together, I get 32. I can keep going, looking at 4 layers, 5 layers. The student can keep building as long as they need to and counting until they notice the pattern, which is 8 is being added to the surface area for each added layer. Therefore, the rate of change is 8. If they want to write the equation, they're also going to need to find the y-intercept, which would be the surface area at 0 layers. Now, theoretically, if we had 0 layers, the surface area would be 0. But in our table, we notice every time we go up, we're adding by 8. So where we have, for layer 1, we have 16, we can just subtract 8 to get to the y-intercept, which is 8. I hope you learned something today. Tell me how you felt about this video in the comments section, and I'll see you next time.